Welcome back, students. We will be looking at section 1.6, terminology for multiplying and dividing real numbers. The multiplication property of 0 can be written in two ways. X times 0 equals 0, or 0 times x equals 0. They mean the same thing. Basically, what it's saying is that any number or variable multiplied by 0 becomes 0. Now let's look at the division rule in 0. So we have two fractions over here. And you'll notice in the top fraction, we have the 0 in the numerator. And in the bottom fraction, we have the 0 in the denominator. There is a difference in what they mean. And it's very important that you understand the difference and that you memorize this. Because later on when we get to graphing, it'll make even more sense, the difference between the two, and it's important to take that understanding that you learn here and add it to the new information that you'll gain in chapter 3. So let's talk about the first one. Basically, you have a 0 in the numerator, and you have a 3 in the denominator. And then it says it equals 0. The reason it equals 0 is, let's look at what I wrote next to it to kind of gain a better understanding. Let's say you ordered a pizza and it was cut into 3 pieces. When it came, you had 3 out of 3 pieces. So you had a whole pizza. But then somebody ate the 3 pieces. You can have 0 left of a pizza that had been divided into 3 pieces if all of those pieces were eaten. So you have 0 thirds. Basically, that's how that fraction would be read. That makes sense. So you would simplify that to 0. You have no pizza left. It's all gone. It's all been eaten. But now let's look at the second one, where the 3 is in the numerator and the 0 is in the denominator. You'll notice I don't have it equaling 0. I have it equaling a word that says undefined. Well, what does undefined mean? That'll make more sense when we get to graphing. But for now, just memorize that the word is undefined. So let's talk about what this means and use our same analogy. Let's say you get a pizza box. You ordered it. There's no pieces in there. So you basically have an empty box. You have 0 pieces, 0 pizza. But you want to eat 3 of the non-existent pieces. You can't do that. You can't eat 3 if there's nothing there originally. If there was no pizza to begin with, you can't eat 3 of those. You can't have 3 pieces of an empty box, okay? So what this basically is saying is you can't have 3 of nothing. So it's undefined. There's no way to define this fraction. So just keep that in mind when you're looking at these fractions. When you read them, this top one, you would say 0 thirds. You can have 0 thirds if there was originally 3 to begin with. But the second one, you can't have 3 of nothing. 3 zeros. 3 zeroths, I guess, if you want to say it in a fractional way. Okay, so moving on to our next rule, the multiplication rules for positives and negatives. When multiplying two numbers with the same signs, the answer will be positive. So our examples, a positive 3 times a positive 3 gives us a positive 9. A negative 3 times a negative 3 also gives us a positive 9. So just remember that if the signs are the same and you're multiplying, doesn't matter if they're positive or negative, as long as they're the same, then you're going to get a positive answer. Now, when multiplying two numbers with different signs, one of each basically, the answer will be negative. So looking at our examples, a negative 3 times 3 gives us a negative 9. Well, then I also flip the order. 3 times negative 3 equals negative 9. So you get a negative answer. So if you have one negative and you have one positive, your answer is always going to be negative. Now let's look at the division rules. So when dividing two numbers with the same signs, the answer will be positive. Look at that, same rule as the multiplication. So if you have 9 over 3, a positive 9, a positive 3, that reduces to a positive 3. So 9/3 equals 3. If you have a negative 9 over a negative 3, and you reduce that fraction, you still get a positive 3. So as long as your signs are the same for both numbers, you get a positive answer. When dividing two numbers with different signs, I'm sure you can probably guess now what the rule is going to be. The answer will be negative. So again, same as the multiplication rule. So what you have to remember is the multiplication and the division rules for positives and negatives are actually the same as each other, which is helpful. So looking at the examples for this one, negative 9 divided by 3 equals negative 3. What if we switch which ones are positive and negative? 9 divided by negative 3 equals negative 3. It's still negative. So if you have one of each sign, you get a negative number. All right, so let's look at some example problems using GEMDAS with the order of operations, basically, with positives and negatives. So number 1, we have negative 4 plus 3. And then we have negative 2 minus 5. We need to deal with that first. And remember our KCC when we have subtraction. So this would become negative 2. Let me write that above it. Negative 2 plus negative 5. If we do our keep, change. That becomes negative 7, because if they have the same sign, we add them and keep it for addition. Now we have a 3, a positive 3, because that's what this plus sign in the front means. Plus 3, or positive 3 times a negative 7. Well, our multiplication rule said if they are different signs, then we are going to have a negative number. So 3 times 7 is 21. And since they're different signs, it's actually a negative 21. Negative 4 plus negative 21, they're the same sign, so we're going to add them and keep that sign and get negative 25. Now that you know the rules for all 4 operations, it's going to be very important that you think through those rules as you're solving these problems. It's very easy to try to go through them really quickly and you intermix your rules and you mess up your positives and negatives, and that completely changes your answer. You'll end up with the wrong answer. So make sure you really spend time learning these rules. These positive and negatives, they're not going away. They will be with you the rest of your time in math. So it's very important that you memorize them so well that you actually eventually don't even have to think about it that much. You just know them deep down. All right, so let's look at number 2. We have negative 5 times negative 5 minus negative 6 times 2. We need to deal with our negative 5 times negative 5 first. A negative times a negative is a positive. It's the same sign. So we're going to get a positive 25. I'm going to bring that down for the next step. We now have a negative 6 times a 2, a positive 2. And remember the rule is if they're different signs from each other, they're going to be negative. So we get negative 12. I'm now going to do the keep it, change. So 25 plus 12. And we end up with 37. Number 3. All right, so number 3 has an absolute value symbol around part of the problem. And we need to deal with that first. So we have negative 10 minus 2 times 4 within there. We need to do the multiplication, the 2 times the 4. 2 times 4 is going to be 8. All right, so now we have this negative 10 minus 8. I want to do the keep it, change. Okay, so that's going to be negative 18. And the reason is because you have the same signs. So that means we're going to add and keep those signs. So negative 18. And now I need to bring that out of the absolute value symbol. And remember, when we bring it out, it's always positive. Okay, so bring that down. I now have a -7 times a -3. This subtraction sign is a negative sign. Remember, we talked about that before. So at this point, I can say -7 times -3. That gives me a positive 21. So when I write this down, I would write it as plus 21. Okay. All right, so 18 plus 21 is going to give us 39. All right, let's look at some more mixed examples, some longer examples. We're going to fill in the blanks as we go here. All right, so number 1, we have a 3 squared. That's what we need to deal with first. So 3 times 3 is 9. And then we just rewrite the rest of it. I went ahead and typed this out to just kind of save us some time. But you would write the rest of it as you go. All right, so we have a 9 here. We already did that. We also have this 4 squared. So that's 4 times 4 is 16. And you'll notice I kept this subtraction sign. That didn't go away because there was no parentheses around it with that 4. All right, rewrite the rest of it. Now we have 9 minus 16. Before we can do the rest of the problem, we need to deal with that multiplication that's in the denominator, the 10 times 3. And that gives us 30. Now we need to deal with our subtraction. 9 minus 16 is going to be... Actually, I'm going to rewrite this over to the side so we can see our... keep it change. So plus -16. And then 7 plus -30. All right. So you've got 2 different signs, which means we need to actually subtract and keep the sign of the larger number. So it's going to be 7. The 16 is larger, so that's a negative. The difference between 7 and -30 is going to be 23. And that 23 is negative because the 30 is the greater number. Now you'll notice in this fraction, we have a -7 over a -23. Remember, a fraction is essentially division. So the division rule is if you have 2 negatives, that means your answer is positive. So if you end up with a fraction that has a negative in the top and a negative in the bottom, the numerator and the denominator, your final answer will be a positive fraction. Okay? All right, number 2. So we have -3 times 2 minus 5 times -6 in the numerator, and then in the denominator, 4 times 3 plus 7 times -4. We need to deal with the first multiplication. -3 times 2 is going to be -6. We have one of each, so that means our number will be negative. The next thing we need to deal with is the 5 times the -6. All right, so 5 times -6 is going to give us -30. I'm going to write that out as keep it change. So I have -6 plus 30. All right, we haven't changed anything else. I'm going to rewrite that in the top line of the next part of our problem, just so we already have that done, and then we'll talk about what the next step is. All right, so we need to do the 4 times 3. That's 12. After that, we need to do the 7 times -4. It's 2 different signs, so I'm going to keep the negative, and that's 28. So -28. We are now at the point where we need to combine through addition. We have 2 different signs, a -6 and a +30. We need to take the difference of those 2 numbers, which is 24, The 30 is greater, so it's a positive 24. In our denominator, we have the same situation. We need to take the difference, and that will be 16. The negative 28. The 28 is greater, so our 16 is negative. Now remember, the rules of division is if you have one of each sign, your number stays negative. And remember, because a fraction is division, we need to follow those rules. All right, so we have one negative. So our whole fraction will stay negative, which is negative 24 over 16. We will need to reduce this. I can reduce both of these by a factor of 8. So I end up with negative 3 halves as my answer. All right, looking back up, look at number 3. We have a lot going on with number 3. We need to deal with our exponents first that are inside those parentheses. 2 to the power of 3 is going to be 8. 2 times 2 times 2 is 8. Negative 2 to the power of 4. That negative is not in a parentheses with that 2, so we're going to keep that negative. And then 2 to the power of 4 is 16. So our resulting number would be negative 16. I'm going to combine 8 and 5 and get 13. And then our negative 16 minus 14, I'm going to come over here and just write that as our keep it, change. So that means we would actually add and keep the sign and get negative 30. All right, negative 3 times 13 is going to be negative 39. 6, let's see, nope, we're not actually multiplying that yet, so I'm just going to fill that in. All right, so now I have negative 39, and I have 6 times negative 30. That's going to give us plus negative 180. Okay. All right, that together gives us negative 219, because we're going to add and keep the sign since they're both the same sign. Now we can deal with the bottom of our problem, the denominator. So I'm going to rewrite the 219 here. All right, so what we're going to do here is to keep it, change. So this becomes plus 1, which is 4. We now have 4 times 4, which is 16. So our answer is 219 over 16. Pretty ugly looking fraction, but it's the answer. All right, now let's look at evaluating algebraic expressions with positives and negatives. Evaluate the following expression if x equals 2, y equals 4, and z equals 5. Okay, so we already know how to do this. We just substitute in. We replace the variable with its true identity, whatever value has been assigned to it, and then we solve. So in this first one, 6x minus 2y plus 3z. The x is 2, so I'm going to put a 2 here. That was a really ugly 2. Let's try that. That's a little bit better. All right, the y is a 4, and the z is a negative 5. 6 times 2 is 12. A negative 2, which is what this is, okay? Or we could just say 2 times 4 and keep our minus sign. How about we do that? Let's be consistent. All right, so I'm going to keep my minus sign. 2 times 4 is 8. Then I have 3 times negative 5, which is going to give us a negative 15. Let's do it that way. I need to go left to right. 12 minus 8 is 4. And then I'm going to bring down my plus negative 15 because I haven't done anything with that yet. 4 plus negative 15, they have different signs, so we need to take the difference and keep the sign of the larger. So the difference between 4 and 15 is 11, and the 15 is greater, So our answer is negative 11. All right, next one. X is 2, so I'm going to replace that with a 2. The Y is a 4. The Z is a negative 5. Z down here is a negative 5, and then the X is a 2. I want to point out this section right here real quick. Notice they have minus Z. So this particular subtraction sign, that's this part right here. So we need to keep that. We brought that down. But when we plug in a negative number, we need to make sure we actually keep that number negative when we plug it in. That's why I wrote it in this manner. So make sure you do that. Don't forget, don't write, do not write it out like this. That is not the same thing, because what you did there was you plugged in a positive 5, not a negative 5. So make sure you do this here. Okay, so let me take this off, and then we'll go through that, just so we don't get confused. Okay, so let me replug that back in. All right, so we have 2 times 4, which is 8. And then we have this, this area here that I'm gonna go ahead and do the keep, change, change. I'm not solving it, I'm just going ahead and changing it. So that becomes a plus 5 in the top. All right, in the bottom, I have 2 times negative 5, which is a negative 10, and then keep the plus 2. All right, 8 plus 5 is 13, and then negative 2 plus 2, they're different signs, so take the difference, which is 8. Keep the sign of the larger. So our fraction is negative 13 over 8. All right, last topic, translating words and phrases. So the product of 5 and negative 2. Product means multiplication. So 5 times negative 2 added to negative 10. So added to negative 10. Next one, twice the product of negative 4 and negative 7. All right, so that means we need to multiply 2 times this whole product of negative 4 and negative 7. Because it says it's twice the product, which means it's twice whatever this becomes, whatever answer it gives us. Subtracted from negative 9. Uh-oh, I've got a turnaround phrase here. So I need to erase what I've written and move it, because I know it's going to be behind whatever it's subtracted from. So let me rewrite that here. So I've got 2 times the product of negative 4 times negative 7. Subtracted from negative 9. Okay, so twice the product of negative 4 and negative 7 subtracted from negative 9. Next example, the quotient of negative 12 and the sum of. All right, that and is indicating we are transitioning from the numerator to the denominator. So the quotient of negative 12 and the sum of, which means we're going to be adding something, negative 5 and negative 1. All right, our last example, the sum of negative 18 and negative 6 divided by, okay, so we know our numerator now, negative 18 plus negative 6 divided by the product of, so divided by the product means multiplication, the product of 2 and negative 4. And we have finished our examples. Let's read our Bible verse. Jesus knew their thoughts and said to them, every kingdom divided against itself will be ruined, and every city or household divided against itself will not stand. Matthew 12:25. All right, guys, look forward to seeing you in the next video. Have a great day. Bye.